Technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the man.
Welcome back, you guys, to another lesson. We are still learning how to become a Cisco VoIP engineer, specifically Cisco, but you can take this information and become any VoIP engineer, any vendor specific, or just a network engineer in general. You can also use this information to build upon if you want to do DevOps or anything in that such, or even into software development. It's really good to understand network engineering and specifically voice network engineering because you're able to understand how data travels through the network and specifically how our phone calls travel through the network. And you must know how data travels before you can know how voice travels, right? So we talked about a bunch of things. We talked about IP phone boot up, which is literally just the phone being connected to the network. We also talked about inbound calling when we actually get a call into our network. Let's say you are a call center agent, you work for AT&T, and you're like, "Hey, thank you for calling AT&T. How can I help you?" We talked about that call flow. We also talked about outbound calling. So if you wanted to make an outbound call to, let's say, your manager, another coworker, or let's just say you're at work and you wanted to order pizza for your team, we talked about how that process works. We also spent a little time about the history of voice over IP and Cisco's role in it. And then we finished up with call manager, CUCM, and clustering. Basically, what is call manager and what does that all entails, right? Now, today and moving forward, let's get CCNP certified. Now, I was doing a lot of research. My goal was to get certified by like end of April, definitely before May, right? And May of this year, 2023. And as I was doing a lot of research, I saw that they are going to update this exam. And they do that every 3 years, they update exams. So I decided to definitely take this exam before they do the new updates because I don't want to learn anything new with it. I had these topics for a long time now, and it's just really time for me to just get certified. So what I'm going to do with you guys is really just give you guys the exam topics every day, probably more than one per day, just so we can get this out the way and I can just go ahead and show you guys how I get certified, right? I gave you guys a PDF on the exam topics. Like I said, we're going to literally go through every single topic, discuss it so you can get certified. And, you can see that I got certified. So moving into today's lesson, because we're all about certifications, okay? CCNP certification to be exact. We're going to talk about infrastructure and design. This won't be a long lesson. I want to try to keep these lessons, honestly, I'm trying to keep them under 30 minutes. They've been like 40, 35 minutes, 40 minutes. So I'm kind of getting there. So I'm going to try to make this one as quick as possible, but still give you the necessary information. Remember all this information is in Notion. So you literally just come to Notion and it's all here for you to review. And this is recorded so you can just review it. So we're going into section 1. Section 1 is about infrastructure and design. So what do they want you to know with infrastructure and design? Well, Cisco wants you to know how is the network, the voice network specifically, actually what are the components of the foundation? What are the components we can start building off of and actually start making that phone call and IP phone boot up or outbound calling or inbound calling? Okay, so let's just start with 1.1. We'll just talk about that one today because this has a lot of information and I don't want to overwhelm anyone with just one video. So we're going into infrastructure and design is 20% of the exam. And we have a few things we're going to talk about, which is 5 topics. But today is the first one, which is describing the key design elements of Cisco Collaboration architecture. Again, we really want to make sure that we are understanding what the exam topic is saying. The exam topic is saying right here to describe. So there's literally no reason for you to try to pull out packet tracer or try to configure stuff or try to look for commands or any of that stuff. You're literally just explaining what these key terms mean. That's all it means. So in this section, what you need to do is make sure that you understand these, key terms. We have 5, 6, 7, 8 key terms. Okay. They want us to describe licensing. How does licensing work in a collaboration network? How does sizing work? What about bandwidth? Also, high availability. We talked about that yesterday or in our past lesson with call manager. What about disaster recovery? Even DAO plans, security, which is our certificates, and how we secure voice traffic, which is SRTP. We'll get into that. And then QoS, which if you was doing your CCNA, you already know what QoS is anyway. Okay. Now, with these things here, I already did the legwork. They already did the research from the Cisco actual book, and as well as this SRND, which is a design guide, and just my own knowledge of being a Cisco network engineer, right? So I gathered a whole bunch of information and I create blogs out of it. So we're gonna actually really go through the blogs. I did add some information to the OneNote, to the Notion. As you can see, there's some stuff that's not in the blog, and that's just to give you more information where you can, you may have questions as you read on, and this kind of answers some of those questions. But let's just take a look at this blog here. Again, we are describing the key design elements of the following. And the following is what I just named: license, sizing, bandwidth, all that good stuff. Now, when you take your CCNP, and you pass the CCNP, you are saying that you are a professional in this field. And a professional in this field means that you know how to build up a Cisco voice network from ground up. Okay, you literally know what cables to use, you know what routers to get, you know all these little things that ensure that we can make phone calls. And I gave you guys a little picture, a little diagram right here, what kind of shows everything that you need to know about as far as design to start ordering these parts and start putting it together. So again, we can start switching traffic. Now, with this diagram at the bottom, we have endpoints. Endpoints we talk about all the time. It's your IP phone, right? A phone in general. Maybe it's a mobile phone. It's your laptop. Or maybe it's a conference room setting, like a video endpoint. Regardless, it's an endpoint. And then we have other things. We have our edge devices. Our edge devices is kind of what the word assists us. Edge, that means that it's a device that sits at the edge of our network, meaning it's going to be a middle ground between the internet world and our network, our internal network. That's an edge device. We have a couple of them. We'll go in later. We have our conferencing. What is conferencing? Conferencing is exactly what it sounds like. It sounds like a conference. Multiple people are getting together and we are experiencing video and audio from what we say Cisco WebEx, but in our sense right now, we can say Zoom. So we have our conferencing servers. We also have our call control. We talked about that yesterday or a past video. Call manager is our call control. Okay, so we have an IMP and we have call manager. Again, these are our main sources to where they're going to originate a call and terminate a call. And then we have our other services that we need, our other applications. And it really depends on what company and environment needs these applications and how many of these applications. But just to give you an idea, one of the applications is voicemail. It's called Cisco Unity Connection, CUC. And that's where it's a dedicated server that does nothing but house our voicemails, okay? Our voicemail box. So when you get a voicemail and let's say it's in a transcript, let's say it's actually written out in, captions and words instead of just listening to it, that data is being stored somewhere. And that data is being stored on our voicemail server. Or even voicemail boxes, like, those voicemails go into a box. And in that box, it has to be held somewhere on a server. And that server is our voicemail box server, right? And that's just one instances, so many other applications we can use. And again, it's just based off of your environment. And of course, we have our firewall, right? We have our another edge device, which allows us to create security between the internet and our internal applications, our internal network. As well, we have our remote sites. We have something that's not in the headquarters, maybe we have branches. So we have devices and end devices and conferencing and a whole bunch of other stuff that can be secondary. And it's usually for our branch sites or remote workers. Okay. So this is kind of what you have to understand on a low level all the way to a high level, which is how do I design a Cisco collaboration, aka a voice network? How do I design this architect? And I just gave you some of the main things that you will need to know to put into place to start designing, right? Now, when you're designing, we have our architectures, our voice network architectures, and they come in 3 different flavors. Our first flavor is on premise. So we can literally, all these things that I said, our end devices, our conferencing, our call control, our applications, the edge devices, all of this stuff can be deployed, which means configured on premises, meaning that we have it on our site at our headquarters or somewhere that belongs to us, belongs to the company, and we are literally managing our own stuff. Okay. Our second architecture is called a cloud deployment. So instead of having it actually on-prem in our building, we can have it to where it's someone else's building. It's we're buying storage, or we're using a hosted service from someone else. Someone else manages the actual hardware of it. We just get a nice little login and manage our own storage. That's cloud. That's our cloud deployment. Now, the third one is you can have a little bit of both, and most of these companies have both. They have not only an on-premise deployment, but a cloud deployment. How is that? Some applications, some servers are actually housed in-house. Like we actually have a systems engineer or a server team that will spin up servers and will spin up our call manager, and we actually do everything there. And then let's say we have our WebEx, which is our call, just our our Cisco version of Zoom. That we probably won't deploy that on premise. We'll probably, get that from somewhere else, get that from another vendor. And we'll say, hey, we would like to use some of your storage. Can we use some of that? Just like we would do with AWS. Can we have some storage so we can utilize it? And they'll lease us the storage. So most of the times you'll see you'll have a hybrid environment. Some services are actually on site, some services are in the cloud, which means that they're hosted by another company. Okay. And it's really based upon the company. What do they want on-prem? What do they want in the cloud? Now, really, before we go on, I want you guys to understand that the cloud is just someone else's computer. Okay. That's all it is. It's not just in limbo in the actual cloud. It's just saying that you don't host that on your own hardware device. Why would a company choose to host? Why would a company choose on-premise versus cloud or vice versa? Well, on premise is really more secure. That means that you have full control over your security of who can come in and who can't come in. When you do cloud, you don't really have that much control over security. You're really just banking off of the company's security that you went to get, use that cloud services from. You're hoping that they're secure. So, do you want your security to be in your hands or someone else's hands? So that's kind of why you may see more hybrid approaches, because some things you can give to other people, but some things you kind of want to make sure that you stay on top of it. You have full control over, because data is sensitive. So it depends on what company you work for. Maybe you work for a bank, you may see on-premise deployment, or you may work for a telecommunications company. You might see cloud deployments. So just want to make sure you put that in your head as far as why would a company, or why would I choose an on-premise deployment versus a cloud deployment? Now, moving on, what they really want us to really go in is read this SRND PA book. It stands for Solution Reference Network Design / Product Architecture. It really goes in great detail about how to really become like a network architect, how to really know these architectures of the voice network and be able to, really design your own. And that's really where it gets to like, $250,000, $500,000 salaries. But you would literally have to have full experience, like real full hands-on experience to get to that type of salary. But at least you can know how to do it on the high end so you can be in those rooms of those architects and then actually become an architect. Okay. So this SRND, I should have it in our notes in our drive. Actually, it's in Discord. So definitely just look into Discord. You will see the SRND book. If you'd like to read it, you can. Most of the time, I just do like Control F to find keywords that I'm looking for, such as if we're looking at the exam topics, I would do Control Find Licensing, Control Find Sizing, Control Find Bandwidth, because I'm just trying to figure out what these all mean. I'm not trying to read the whole book. Okay. And you can do the same thing. Now, in this SRND, it really just covers these 10 things about the architecture, which is what we talked about: the endpoints, the network infrastructure, call control, media service, collaboration service, management and monitoring service, security, scalability, high availability, and integration. Most of these things just try to kind of like come to you anyway, right? We know what endpoints are. We know what the network infrastructure is. It's nothing but the routers, the switches, and actual hardware devices. We know what the call control is. That's our call manager, our CUCM. We know what media resources are. Media resources is just like if we wanted to transfer a call or music on hold, or press 1 for sales or press 2 for customer service. That's a media service. We also have collaboration service. That means that's something that we can collaborate on. When you think about collaborating, you can think of things such as WebEx, aka, something like Zoom. You may think of something as far as like instant messaging, like Discord, what we would call in Cisco Jabber, right? So that's collaboration services. We got management and monitoring. So that's where we can actually manage and monitor the system. We have a couple services for that, something like Cisco Prime or Unified Reporting. We also have security, like we talked about, firewalls, VPNs, intrusion prevention systems, all that good jazz. We talked about that in CCNA. Scalability. Scalability is great because we're going to grow as a business. We're going to start off with 100 employees, but then we're going to grow to 1,000 employees. So we need a plan that we can have to scale our network. So we want to have, let's say we do have 100 employees, but we kind of maybe want to have maybe 20 more devices on the side, because we plan on growing and adapting and hiring more people. So we'll plan for our 100 employees, but we'll also make sure that we do a little more, which is probably 20 extra employees. So we'll probably order 20 more phones, or have 20 more licensings, or update our bandwidth, right? That goes right into high availability. We want to make sure that these services, these routers, these switches, our servers are always up. They need to be up 24/7, 365. And if they go down, because that's just what technology do, especially when you're running it 24/7, you need to have a failover, redundancy. You need to have something that says, it's okay. The first one went down because they tired. I'm here to come in the backup, and you can utilize me and my sources until the first runner gets back up from whatever they went down from. And lastly, integration. Integration, we want to integrate with so many other systems. We really don't want to have, I guess you can say everything Cisco, because Cisco cannot create everything. Cisco cannot, Cisco is the leader in all IT solutions. However, there are other systems that we want to use. There are other vendors that we use for multiple different reasons. One reason is we are a company that's Cisco based, but let's say we're doing business with another company and they're not Cisco based. How are we supposed to collaborate with them and do business with them? Well, we make sure that we have a system for, or at least a service for integration. We can integrate other systems that are maybe not Cisco proprietary, or maybe they are Cisco proprietary. We just can use them at an ad hoc basis. Okay. Now, moving into the actual exam topics for 1.1, which the first one is licensing, smart flex. There's a licensing called smart licensing, and there's a one that's called flex licensing. The difference is based off of what you need in your system. Okay. Flex is what it is. It's flex. It's allows you to be flexible in your licensing. And then smart licensing is kind of like the regular licensing. It's actually a license that's already on a routing device, and you literally just activate it. You literally just enable it. Why do we need licensing? Just think about it as you needing a driver license to drive. Everyone in America needs a driving license. Okay, you get pulled over, they say license and registration. So it's the same thing. Anyone in our network that needs to send data, that needs to drive their data or their call from one place to the next, they need a license to do that. They need to say, hey, you are authorized. Your phone is authorized to make and receive phone calls. Okay, so we need that license. We have to pay for those licensing. And that is all based off of the how many users you have, how many devices you have, and a whole bunch of other little things here. But you really want to know the difference between smart licensing and flex licensing. All right. There are 3 areas that need to be licensed. We have the call manager, the CUCM software. So that actual software that we just spun up on the server, we need that license. We need to have a legitimate license that we can use Cisco software. The second area that we need licenses, like I said, the devices. How many devices are going to be used? How many devices are going to be registered to this call manager? We have to pay for that. They need a actual license. And then our extra nodes / applications, right? So we have call manager, which is our main wheelhouse, but we talked about so many other services that we need, such as music on hold, TFTP, voicemail, a whole bunch of other things. We have to have licensings for those servers as well. So licensing can get pretty expensive, but we work for a Fortune 500 company, so it's okay. We want to make sure that we're in budget. We want to make sure that we're also within our legal rights to use Cisco software and Cisco applications. Okay, that's the whole point of a license, is to say that you're legally able to do something. All right. Next is sizing. What is sizing? Kind of goes in more into licensing, because you need to know an accurate estimate of how many routers you're going to order, how many switches you're going to order, how many IP phones you're going to order, what models of IP phones you're going to order. Remember when we talked about PVDMs and DSPs? Those are actually the chips that go onto the voice router. So how many PVDMs do we need? How many DSP resources are we going to use? So we have to have a correct sizing of the hardware. We need to know how much traffic are we expecting. Is this a company that's just going to have a phone at each desk, and they just make calls on as their job goes? Or is this a call center where they have soft phones and the call flow is just coming in every second there's a call, right? So we have to know what we're getting involved in here, and that'll really allow us to continue on with planning and developing our voice network. Okay. Going on to developing our voice network, we have bandwidth. So now we know how many people, how many devices we need, how many people are going, or at least, again, and I wouldn't say people, but at least how many IP phones are going to be registered to the call manager, how many calls we're expecting to have. Is this a call center environment, or is it a sales environment, or are we just we just need a phone to be able to call every now and again? With that in mind, we need to know how much bandwidth do we need, because we don't hold our own internet. regardless of what you think, we have to go and buy internet. We have to go, just like you call AT when you move into an apartment, you got to call AT&T, or you have to call Comcast and say, hey, I'm moving. I just moved here. I would like internet service. And then they give you some residential plan. It's kind of the same thing on the enterprise setting, but they're going to give you an enterprise plan instead of a residential plan. So they're going to give you the allotted bandwidth that's needed. And you would go through the details with the service provider. And most of the time, you're dealing with codecs when you're dealing with bandwidth. Codecs, we talked about that. That is compression, decompression, codec. Okay, right here you see CODEC. That's basically just compression, decompression. That means that we are going to compress our audio so it can traverse over a WAN link. What is the WAN? Wide area network is nothing but a whole bunch of local area networks put together. So our codec, it helps our audio call traverse against all over the world so we can get to its recipient. It can get to the other side. And that other side will literally decompress the audio so the audio can now come through to the phone. Okay, it's some type of mathematical equation that happens. You don't need to go down that far, but what you do need to know is that bandwidth, codecs, they're equal to each other, and you need to know the how you would provision bandwidth. Okay, and it's all based off the codecs. We talked about popular codecs. We talked about G729 and G711. The differences is something that you need to go in and kind of understand what is similar and what's different about it, and other codecs as well. I'm not going to go deep into it because that's going to end up taking this lesson for an hour, for probably a couple hours. But I do want you to understand that you need to basically provision your bandwidth. You need to say, hey, service provider, we need X amount of bandwidth, and this is why we need it. How do you come up with that number? And you come up with that number through the codecs. All right. Moving on to high availability. So we have our bandwidth. We know exactly how much bandwidth we have allocated to us that we can use. We're using our correct codec so we don't use up all our bandwidth. So now we're making sure that we have our high availability, that our servers, our routers, and our switches are up. So the end user is just making phone calls and utilizing their resources as they should. And if anything happens, let's say a server do go down, another server will come back up in its place, and it will not affect the end user. The end user doesn't even know that just happened. We knew because, we got so many alerts, and we're scrambling. We're frantic in the background. But our end users don't even know that this is happening in the background because we have high availability. We have redundancy. Okay? That is so important in your career as an engineer, is high availability, aka redundancy. All right, I cannot stress that enough. That will keep you in a job. Okay, or it will make you lose a job if you do not understand high availability and redundancy. All right, disaster recovery is our next topic. Disaster recovery is exactly what it kind of sounds like. It is a recovery of a system in case of a disaster. And we can all think of it in simple terms of a backup and a restore. Okay. Your iPhone has iCloud, and it probably, every time it connects to Wi-Fi and you have it plugged into a charger, it probably backs up to your iCloud drive. And that's exactly what this disaster recovery system do. It literally is going to back up and save all our configurations, save calls as it's coming through our system, save changes, adds, deletes, all that good stuff. It's going to tell you who did what, when, where, and why. And in case anything happens, like a power outage, let's say that, it got, unexpectedly cold in the area and all the power just, froze, and the pipes froze and everything went down and no one had, electricity or anything, then guess what? The whole call manager goes down, your servers are down, but we have a disaster recovery system, meaning that it's already been backed up all until the last minute, the last second that we lost power. And once we get power back on, we can restore all that from the disaster recovery system. We can restore all the configurations, everything back to normal like it didn't happen. Okay. The disaster recovery system also backs up details with call records. I've been in a lot of cases to where maybe something had happened to where the FBI or the police, CIA, whoever, they would come to us and say, hey, we're going to need call records from these dates and these time frames. And we have that in our disaster recovery system. So we can literally just pull up those times and say, well, this is what we do have. Okay. And we need that for legal purposes. At least that's what I've been experiencing. It really comes in with legal purposes. Now, on a smaller scale, you may have a petty manager, and you probably lied to the manager like, I did clock in at 8:30, and you probably only clocked in at 9:30, and the managers probably just like want to be petty and double check. They would come to us and say, hey, can you provide me with some call records to see when this user logged in into the phone system, or when their first phone call was, or even if maybe they well, the manager kind of has some of the information, but they won't have it in full detail. So they may even say, can you see to see if this user hung up on this caller, or did this call in naturally, right? Again, it's usually petty managers want this information, but we have it and we provide it. So disaster recovery literally houses and records all of the traffic that flows through and all of the settings that flows through the call manager and other services. But really the main wheelhouse, which is the call manager. The next topic is dial plan. We talked about the dial plan, but we're going to go in a little bit more. The dial plan is literally nothing but a agent that says, hey, this is how you route calls. Okay. So a dial plan is saying, you as the engineer puts the dial plan together. You say, okay, this is your phone number, and this phone number can reach these other phone numbers. This is how you get to these other phone numbers. And if you want to dial 9 to get out, this is the dial plan is you have to press 9 to get out of the company's network, or you can press 355 and get to, warehouse. That's what is consisted of a dial plan, right? It's literally telling you how your call should be processed. And we need that information. We need to know how that's the meat and potatoes of calls. Like, if you make a call as a regular agent at work versus your manager making a call, I bet your manager can call more people than you can. Or your manager can probably get more calls, receive more different calls than what you can. That's part of the dial plan. Okay. So we need that. Moving on, security. Security. We always need security. First thing is certificates. Certificates is basically saying that we are authorized to use a certain service. Okay, we are authorized to ensure that this service is, again, not only authorized but secure. Secure that if you put your information in, you won't get scammed, for an example. So let's talk about let me see, what's an example? Like websites. You probably may or may not realize, but in a website, you see this little lock right here. This lock is basically housing a security, and this security is housing a certificate. And the certificate is saying that, is this a trusted site or not? If the lock is open, it's not a trusted site. If the lock has a X, it's not a trusted site. If the lock is red, it's not a trusted site. But if the lock is just secure, it's just regularly grayed out, you see that it actually is locked, then you have nothing to worry about. So you may go to websites to where the browser right here, the URL bar, probably has a red lock or something red there. That means that alert. You may not want to put your credit card information in or sensitive information in. Okay. But as you can see, excuse me, this is Technically Speaking site. It's secure, it's locked. So it means that it basically has information pertaining to it that is secure to where you can go ahead and put your personal information on this site, and you don't have to worry about fraud or identity theft or anything in that regard. Same thing for us in enterprise. When we when we deploy call manager and call manager servers, we need a certificate to show that this server is secure. So we literally have to upload certificate to the server, and we have to get it signed by other people, and it goes down the rabbit hole. I think I have a few things in Discord about certificates. If not, I will upload it. But definitely go in and learning about certificates, which are, critical to secure connections, and also these terms right here, SRTP and TLS. SRTP is Secure Real-Time Transfer Protocol. So when we transfer our voice, our audio over the internet, and use a type of signaling protocol, which is called RTP, Real-Time Transfer Protocol. Real time. In real time, I am speaking, and in real time, you are hearing me. That is called RTP. It is a real-time transfer protocol. But that's not secure. So we need a method to secure this audio, because what if I'm talking to you right now, but I'm only want to talk to a certain number of people or a certain type of users? Not everyone gets to hear my audio. I want to, basically organize that traffic, or really just secure that traffic and encrypt it. Then I can do so with SRTP, which is nothing but a secure version of real-time protocols. And that's exactly what it is. It's secure real-time transfer protocol. Okay. TLS. You may see TLS even in our website browsers. If you're more on a website developer end, or you kind of like built, websites like Wix or Shopify and stuff, then you probably see TLS a lot. TLS is the transport layer security. It's literally the protocol to where you transfer data, but in a secure way, on a secure layer. Okay, you'll see TLS a lot, but as you keep going through your network engineering and specifically voice engineering path, you will see RTP like no other. And then, of course, you just add an S on it and a secure RTP. And then lastly, we have QoS. You guys should already know what QoS is. It stands for quality of service. Why do we need quality of service? Because without quality of service, traffic will just go anywhere, everywhere. You may get an email before you get a phone call because we don't have quality of service enabled. Quality of service allows us to organize traffic so priority traffic can actually get there first before non-priority traffic. So an example, would you rather get an email first or a phone call? If you're at work, and let's say you are a call center agent, but you also deal with chat and emails, and let's say that, or let's not even say you as a worker, let's say that you're actually the person that needs help. Or when you need help from someone, would you rather email them, or would you rather just call them? Would you rather just chat them, or would you rather the email? So we want to know what's priority. First, phone calls are priority because you don't want to sit there and have to read through documentation. You probably really need help, like right now. Like, my phone does not work. I'm calling Apple. I need my phone to work. So you're going to want your phone call to be the first thing that goes through, then an email, right? So voice is always priority. Voice and audio call needs to go through the network first. And then you can get an email, a chat, watch a video, play a game, browse the internet. Okay? And they're literally numbered into what's priority and what's not priority. Okay? So QoS, we talked about that. Quality of service is just a way to organize priority traffic over non-priority traffic. And if we go back over to our Notion over here on the left, it kind of gives you a little bit more information about QoS and the techniques and the technologies in QoS. Like, we have quality of service, class of service, COS. It's a marking, and that marking says you're priority, you're not priority. You're a priority, you're not priority. Okay? It's some more stuff to go in. I definitely suggest you give this a little read here. Honestly, you should probably already know quality of service. If you don't, go back to CCNA. It gives you a whole lesson, probably like 2 hours worth of QoS, because you really need to fully understand it. Okay? Again, This is describing key design elements. So there's no need for you to go in and start configuring, looking for commands. You really don't need to get overwhelmed with this because all you're doing is describing it. How I just described it to you, you should be able to describe it back. If you're able to do that, you can move on to the next section. But I really want you guys to understand what the exam topics are saying, because sometimes you will get overwhelmed. It's so much information, but the exam topics, they just want to know, can you describe it? They don't want to know if you can actually configure it, because that would be for the next exam, which is the CCIE. That means that you came from a professional to an expert.